Okay guys, so I don't know if you can remember anything about perms and cons yet, but we were just looking at how to figure out how many different possibilities or outcomes there would be for certain situations. And we just started looking at if we had restrictions with those outcomes. So I don't know if you remember it, but number 3 in the class example, Eric had to figure out how many odd 4-digit numbers there were, but now we're going to look at the cases where you have if you have even numbers. So maybe just to refresh your memory, if we were looking at odd 4-digit numbers, okay, there's 4 digits, what would our last, how many possibilities for our last digit would there be if we were looking at an odd number? Okay, we have possibility of ending with 1, 3, 5, 7, or 9. So there's 5 options for it to be an odd number. If for a 4-digit number we can't have 0 as the first digit, then that means we have 9 possibilities for the first digit. Okay, and then this could be anything 0 to 9, so that would be 10, and this could be anything 0 to 9, which is 10. So that's if repetition is allowed. Okay, but what if repetition is not allowed? Okay, if it's going to be odd, that means we can choose numbers 1, 3, 5, or 7. So we have 5 options. The first digit cannot be 0, and not the last digit. So that means we've taken out 2 possibilities from the total of 10 possibilities. So the first digit could be 8 possibilities. 8. Now we've used up 2 digits for the first and the last digit. For the second space, how many options do I have if I can't repeat the digits that have already been used? 8. Good. So can't repeat first or last. Okay, and then this one, if I've used up 3 digits, I have 7 possibilities. Okay, and then using the fundamental counting principle, we would just have to multiply these and figure out what is the total number of outcomes for odd numbers if you can't repeat or if you can repeat. Okay, so that was just a little refresher of what Eric did in the example number 3. Now we're going to extend this and we're going to look at, Eric's been asked how many even 4-digit numbers are there. Okay, and then part 2, how many even 4 digits are have no repeated digits. Okay, so let's just do the first one. So even 4-digit number. Okay, it doesn't say anything about repetition. So for even, that's also, we have 0, 2, 4, 6, 8. We also have 5 possibilities. Okay, the first digit cannot be 0. That means we have 9 possibilities. The second digit can be anything from 0 to 9, so that's 10 possibilities. And the third digit can be anything from 0 to 9, so that also has 10 possibilities. So we just have to multiply that through, and we get 4,500. So that's how many even 4-digit numbers there would be. Okay, so for part 2, we're not allowed to repeat any of the digits, and there's going to be 2 cases that we're looking at. Okay, so Eric started to answer number 2 as shown below, but he was not sure how to fill in the first space in his work. Explain why he needs to consider 2 separate cases to solve this problem. Okay, so actually we need to ignore this work here. There's going to be 2 cases. So the first case is if we end with 0. And the second case will be end with 2, 4, 6, or 8. Let's look at the case if we ended with 0. So So if we ended with 0, that means we have one choice. The first digit, we know if it's a 4-digit number, cannot be 0. So if we've used 0, and the first digit can't be 0, how many choices do I have for the first digit? None. Good. Okay, and remember, we're not allowed to repeat. So once I've used 0 and some other digit, I've used up 2 digits, so now I have 8 choices. This is not first or last digit. Okay, now I've used up 0 and 2 other digits, so I've used 3 digits. How many do I have for the third place? 7. Okay, good. So now I just multiply this. Okay, we end up with 504 possibilities. Now let's look at the second case. So it's still a 4-digit number, but we're going to consider the case where our last even number is 2, 4, 6, or 8, which means I only have 4 choices. The first digit won't be 0 or last digit. So if it can't be 0, it can't be the last digit, that means I only have 8 possibilities. And then once I've used up these 2 digits, I have 8 possibilities. Once I've used up 3 digits, I have 7 possibilities. So we multiply this through. And we should get 1,792. So one thing that's really important about these lessons, or this lesson, was we learned what the word OR means. What does OR mean in math? What operation will we use? Add. Good. Okay. So in this case, it's not really described to us, but I have shown you that there's 2 cases. It's either going to be case 1 or, sorry if my marker's not working, it's going to be case 2. So what do I do if I see the word OR? I have to add the number of possibilities from case 1 with the number of possibilities from case 2. Okay, so total even digit or 4-digit numbers with no repeated digits would be 504 plus 1792, and our total will be 2,296. So the other class, they really questioned me on this one. They're saying, well, how come with odd digit numbers you didn't have to do 2 cases, but with even digit numbers you did? Well, you had to consider that with 4 digits, the first digit cannot be 0. So if that's the case, and that's one of the even digit numbers, we had to consider, well, what if the last digit was 0? If it is, then I actually have 9 choices. But say your last digit is a 2, then your first digit also can't be a 2 or a 0, so you only have 8 choices. So there's 2 different scenarios where if 0 is used, you have a different number of outcomes. Okay, so just remember, if you see a question like this, that you have 2 cases, and then you add the outcomes together at the end. Okay. Now let's take a look at the word English. We're going to consider the number of distinguishable 4-letter arrangements that can be formed from the word English. Okay, just note there's an implication that the letters cannot repeat. Okay. Okay, so each one of these letters will only occur once. Determine the number of 4-letter arrangements that can be formed from the word English if we have the following cases. Okay, so there's 4-letter words, any letter can be in any position. So for the first position, how many letters do I have to choose from? 1, 2, 3, 4, 5, 6, 7. Okay, so 7 possibilities. Any letter. If letters can't repeat, how many options do I have for the next one?
6.
And then the next one?
5.
And then the next one? 4. So we just have to multiply these. So when you multiply that, you should get 840. Okay, next one. First letter must be E. If the first letter must be E, how many choices do I have for that? 1. Okay, and then any of the other positions can be any letter. But I've already used E, so I have 6 choices left. And once I've used 2 letters, I then have 5 choices. Once I've used 3 letters, I only have 4 choices. Then we multiply using the fundamental counting principle. I get 120. All right, next one. First and last letters must be vowels. So if we take a look at the word English, we have vowels E and I. So the first digit will be E or I. So that means I have 2 choices. If I've used an E as the first digit, then that means I have only 1 vowel left for the last digit. Okay, and then any of the middle letters could be anything from English except for E and I. So I have 1, 2, 3, 4, 5 left. And then once I've used 3 letters, I only have 4 left. So we just multiply. So this says 40 possibilities. Now this next case, we have to consider actually 4 cases. Okay, you can have a word that's 4 letters where the G would be in the first position. Or you can have a word with 4 letters where the G is in the second position. Or you could have a word with 4 letters where the G is in the third position. And the last scenario would be when the G is in the 4th position. So we have to consider all of these cases, and then we can add up the outcomes to get the total number of outcomes. Okay, so if G is in position 1, there's only 1 choice. We've used 1 letter, so now there's 6 left, 5 left, then 4 left. Multiply these through, we get 120. Alright, but what if G is in position 2? There's only 1 choice for G. I've used 1 letter, so I have 6 letters, then 5, then 4. Is it going to be the same for all 4? Yeah. So we have 120 plus 120 plus 120. That gives me 480. Okay, so there's 480 possible ways I could have G in this.